Hello, my name is Luis Patino from University of Reading in the United Kingdom. I am part of the PETS 2021 committee, and I am very honored to be presenting the overview and results of evaluation in PETS 2021. I would like to start by thanking, on behalf of the PETS committee, our hosts, the AVSS 2021 organizers, for accepting this challenge and for the support they have given to us, and to the European project FOLDOUT, who is sponsoring this challenge and who facilitated the collection of the data. In PETS 2021, we introduced a novel video surveillance dataset for person detection and tracking, and particularly oriented towards through foliage detection, and thus including fragmented occlusion. The challenge evaluation is based on the submissions that we received from 6 international participants. The recordings in the introduced dataset correspond to natural environments typical of land borders. Such environments present the challenge of fragmented occlusion, where multiple body parts of a person may be occluded, and particularly from foliage, and little attention has been paid by the computer vision community to this problem. The challenge is thus to perform robust person detection and tracking in such environments. The dataset contains 4 single-camera videos containing one or more persons moving through the scene. The common characteristic is that they are always moving through foliage. The different challenges in this data include that the detector has to deal with different modalities, RGB or thermal cameras. There are different degrees of occlusion given by the foliage, and the distance of the person to the camera varies across sequences, so that the size of a person is not the same in the different sequences. The first challenge in PETS 2021 is on person detection. There are 3 sequences on this challenge, and as you can see, the detector has to deal with the strong levels of fragmented occlusion given by the trees and foliage in general. The submission requirements were for sequence 1 and 2 to report the bounding box of each person in every frame of the sequence, and for sequence 3 to report the XY position in pixel coordinates of each person in every frame of the sequence. This XY location could be based on the generated bounding boxes for traditional detectors, or on alternate representations for fragmented occlusion. The second challenge in PETS 2021 is on long-term tracking, to follow one person even when going through foliage in one video. The submission requirements in Challenge 2 were to report the location of the person in every frame of the sequence. Authors had the possibility to provide either bounding boxes or point locations as XY pixel coordinates. Ground truth annotation was created by a professional company. Every 3 video frames, unique person identifiers were created. These could be individual points for visible body parts, or ellipses, or bounding boxes. Bounding boxes were interpolated for intermediate frames. We received submissions from 6 international institutions. Some would submit multiple methodologies. Some would submit only on selected sequences. In general, all institutions submitted results for sequence 1 and sequence 2 in challenge 1, and for sequence 1 in challenge 2. Some institutions did not submit results for sequence 3 in challenge 1. The methodologies employed were diverse, and at the same time it is worth mentioning that popular deep learning architectures such as YOLO 5 or Mask RCNN were implemented on several submissions. The results in PETS2021 are reported either as bounding boxes or as unique points representative of the detected person. To achieve uniform evaluation, we proceeded as follows. For submitted results, we employed either the XY location reported, or we calculated the midpoint of reported bounding boxes. For the ground truth, we calculated all midpoints from annotated bounding boxes. Then we matched submitted results and ground truth via the application of a Hungarian algorithm. For the evaluation, we calculated standard measures such as precision and recall, which are based on the calculation of true positives, true negatives, false negatives. Furthermore, we calculated the clear mode metrics, the multiple object tracking precision, and the multiple object tracking accuracy. MOTP is actually a measure of localization precision. It gives the average distance to similarity between true positives and corresponding objects in the ground truth. And the MOTA measure is defined from 3 ratios: the number of misses, the number of false positives, and the ID switches in the track. Coming to the results in challenge 1, in sequence 1, the people to detect are of relative big size relative to the image. The challenge then is to retrieve the different parts of the person through foliage as a single entity, and not to produce false positives separating different visible body parts as different people in the image. In this sequence, Boston University achieved the highest accuracy and recall. And we have some sample images explaining why Boston University recall measure was so high compared to some other submissions. In sequence 2 of challenge 1, the level of occlusion is considerably increased, and there is a corresponding increased number of false negatives for the different submissions. So we observed actually 10 out of 12 submissions have a recall which is less than 50%. Boston University achieved a recall of 83% with also very few false positives, thus achieving high results of precision, accuracy, and specificity. And here we have some examples of some of those best detectors compared to some other submissions. In sequence 3 of challenge 1, the level of occlusion is very high, but also the targets are smaller. Some submission produced a larger number of false positives or an increased localization error. In this sequence, University of Reading YOLO implementation achieved overall the best results with no false positives. Here we have some examples of the difficulty to achieve the person detection and some accurate detections given as a point detection in the submitted results. In Challenge 2, for the single sequence provided, the challenge was to perform long-term tracking with a small target. And although most detectors perform uniform tracking, Boston University achieves the highest MOTA. Its results in accuracy, precision, recall, and specificity show that the detector in itself manages to detect persons at limits of visibility which other detectors did not achieve. Again, just some examples to show the capability of Boston University Tracker compared to some older submissions. In conclusion, PETS2021 introduces person detection and tracking challenges on challenging environments with significant levels of occlusion. We had 6 international submissions, and deep learning methodologies dominated the employed methods. Boston University performed best in practically all sequences, but all submissions demonstrate that detection and tracking remains still an open problem where difficult conditions are still to be tackled, especially in foliated environments. The future work can seek to improve detection and tracking in these unrelated environments. Many thanks indeed for your attention. Many congratulations to Boston University, and many thanks to all participating institutions. Thanks.